In this video, we're going to focus on understanding electrostatic potential energy. Electrostatic potential energy is the energy associated with two charged particles. Hopefully we can see the importance of understanding electrostatic potential energy as we've already been looking at protons and electrons within individual atoms. Eventually, we're going to be looking at how electrons and even protons to some extent influence chemical bonding. So we'll be looking at the interaction of charged particles in a number of different scenarios. First, let's take two charged particles. If these charged particles are separated by an infinite distance, we define that electrostatic potential energy as zero. I'll go ahead and place that point of infinite distance on my plot here. So we'll look at like charges and opposite charges. Both at an infinite distance are at energy of zero. So for the first case, let's look at the like charges. What do you think is going to happen to the electrostatic potential energy as these particles get closer and closer together as a smaller distance? Well, there is a repulsive force between like charges, just like there's a repulsive force between like poles on a magnet. And the surroundings must do work in order to bring those like charged particles closer together. And so work done on the system being my two charges, would result in an increase of internal energy. So as the distance decreases, my energy increases and will eventually approach a maximum. So these are getting closer and closer together as we increase in energy. Now for opposite charges, as those get closer and closer together, what do you think happens to the electrostatic potential energy? Well, there's an attractive force there. And so the system is actually doing work on bringing them closer together, so the energy is going to decrease as those opposite charged particles come closer together. So we have positive and negative getting closer and closer together. And this relationship is actually derived from Coulomb's law. So from Coulomb's law, we can say that the electrostatic potential energy is proportional to the charge of the particles and the distance that they are separated by. Let's look at a few different scenarios. Let's say we have A and B here. Which will be at the higher electrostatic potential energy? Well, we have two like charges in both scenarios separated by the same distance. So if we use our relationship derived from Coulomb's law, in scenario A, the electrostatic potential energy will be proportional to +2 times +1 over d, which would be 2 over d. In scenario B, the electrostatic potential energy would be proportional to +1 times +1 over d, which would be 1 over d. So which is larger? A is larger. So A will have a larger electrostatic potential energy than B. You give this one a try. Which will have the higher electrostatic potential energy, A or B? If we use the same approach, the electrostatic potential energy will here will be +2 times -1 over d, or -2 over d. And then the electrostatic potential energy here would be let's do +1 -1 over d. So this would be -1 over d. So which one is larger? Well, -1 is larger than -2 over d. Because think about a number line, right? If we have a number line and we're at 0, -1 is here, -2 is here. So we are farther from 0, indicating a smaller or a more negative number. So B actually has a higher electrostatic potential energy. How about this third scenario? I changed the distance on us. How does that influence the electrostatic potential energy? Can you tell me which is the highest electrostatic potential energy of A and B? We can take the same approach here and say that the charge plus 2 minus 1 over 2d is equal to minus 2 over 2d, which is equal to 1 over d, minus 1 over d. And the electrostatic potential energy of my second system here, plus 1 minus 1 over d, is also equal to minus 1 over d. So these two systems actually have the same electrostatic potential energy. So we can see that both charge and distance will influence electrostatic potential energy in some way. Please keep in mind the sign and that number line. As we get farther from 0 in the negative direction, we're getting smaller and smaller. So if you have any questions, please let me know. Thanks for watching.